Hello everyone, welcome to my next video. In my previous video, we were discussing about the types of pharmacokinetic models. So there are three types of pharmacokinetic models are there: compartment model, perfusion or physiologic model, and non-compartment model. So we'll discuss one by one. So the first model is compartment model. As we already discussed, compartment models means it is the different compartments, like in train has different compartments, like one compartment, two compartment, three compartments. So there are so many compartments in train. Similarly, we are going to explain the pharmacokinetics of the drug using the body dividing into different compartments. So depending upon the number of compartments, so the compartment model can be classified as one compartment model, two compartment model, and multi-compartment model. So this number depends upon the number of compartments. So if the compartment model divides the body into a single unit, then that model is known as one compartment model. If body is divided into two compartments, then it is two compartment model, and if it is more than two, then comes under the multi-compartment model. So how, on what basis the compartments has been classified or divided? So how it is depending upon the similarity in the tissues. So all the tissues which are having similar in some properties. So mainly which properties are to be considered during similarity? One is the blood flow, that is perfusion to that particular organ, and another is permeability of drug to that particular organ. How much blood flow moving to that particular organ. If blood flow is same to some group of tissues, that will be placed in some compartment. Similarly, not only the blood flow, also the permeability of the drug. If the drug is highly permeable, then those tissues will be considered to be a one compartment, and where the tissues which are responsible for less permeability, those will be in the another compartment. So mainly depending upon the blood flow and permeability of the drug, body will be divided into different compartments. Like if whole body the distribution is even or instantaneous, then whole body will behave like a single unit. Then there the model followed will be one compartment model. If the distribution to one organ and then the distribution of drugs takes place from those organs to other organs where the less perfusion of drug takes place, then that is two compartment model. If the distribution takes place in three steps, then that is the three compartment model. So depending upon the distribution, the drugs, how they are distributed in the body, the compartment models also will be divided into different types. So already I said you have to consider this both point. Like generally there are two compartments are there. Matlab you have central compartment. Different compartments are central compartment, peripheral or tissue compartment, and we have shallow tissue compartment and deep tissue compartment. In one compartment model, only central compartment will be there. Whereas in two compartment model, central compartment and peripheral or tissue compartment will be there. Whereas in three compartment, we have central compartment, and in tissue compartment we have further two shallow tissue compartment and deep tissue compartment. So what all the tissues will be placed in these organs, in these compartments? So mainly plasma will be always in the central compartment. Apart from that, highly perfused organs. So which are all known as highly perfused organs? The organs where the blood flow will be higher or greater, like vital organs like heart, liver, kidney, lungs, the blood flow will be higher. So these organs are known as highly perfused organs along with brain. So all the highly perfused organs and plasma will be always placed in the central compartment. and less perfused organs. Next to this we have skeletal muscles, adipose tissues, those will be placed in this less perfused organs. And there are some tissues where the drug will reach very lately because of very less perfusion of blood. So that is known as deep tissue compartment. Got it? So we have different organs. So central compartment, I told all the highly perfused organs will be placed in this central compartment, but not always. Depends upon also the permeability of the drug. Consider if the drug is polar in nature. Polar drugs are water soluble in nature. So polar drugs cannot permeate through the blood-brain barrier. Blood-brain barrier permeation of polar drugs is less. Why? Because blood-brain barrier permeate only lipophilic drugs to pass through. That is, lipid soluble drugs can easily pass through the blood-brain barrier, but not the polar drugs. So polar drugs cannot permeate through the blood-brain barrier. So in case of polar drugs, brain can't be in the central compartment, brain will be in the peripheral compartment. So while you divide the compartments, you not only have to consider the blood flow, you have to also consider the permeability of the drug to that particular tissue. Like in case of polar drugs, it is not permeable to the brain, so brain cannot be placed in the central compartment and it is placed in the tissue compartment, because distribution of drug to the brain in case of polar drug will be less. So it cannot take the place in central compartment, it will take the place of peripheral or tissue compartment. So we have to consider all these points and then we have to divide the tissues or group the tissues in different compartments. Let's start with one compartment model. So one compartment model means we are here, the assumption is that whole body is considered to be single kinetically homogeneous unit. Kinetically homogeneous unit. What does it mean? मतलब whole body is considered to be a single unit. पूरे बॉडी को हम सिंगल यूनिट मानते हैं, एक ही यूनिट मान रहे हैं. किस बेसिस पर एक यूनिट मान रहे हैं? डिपेंडिंग अपॉन द काइनेटिकली होमोजीनस. अब होमोजीनस का मतलब क्या है? व्हाट डज इट मीन? होमोजीनस मींस सिमिलर, सिमिलैरिटी. सो किसके बेसिस पर सिमिलर है? ऑन विच बेसिस इट इज सिमिलर? Kinetically similar. Kinetics means movement. The movement, the change in the drug concentration will be similar in all the tissues. So whole body is considered to be single kinetically homogeneous unit in case of one compartment. पूरे body को एक ही compartment मान रहे हैं. That is, we are considering whole body into a one compartment. While the assumptions of this one compartment model are distribution is instantaneous. What does it mean? Instantaneous का मतलब क्या होता है? Immediate, fast, rapid. So instantaneous मतलब तुरंत, immediately. So distribution, when the drug enters the blood, it distributes very fastly to the all tissues. So that is known as distribution is instantaneous. Since it is considering the whole body as a single unit, once it enters into plasma, you can find the drug in any tissue, because distribution from the blood to any tissue is rapid or instantaneous. That is why distribution is instantaneous. अब कभी भी compartment models लिखते वक्त we have to write the assumptions of that. So first one compartment model का first assumption क्या है? Distribution is instantaneous. What about next point? Now distribution is instantaneous, whereas elimination follows first order kinetics. डिस्ट्रीब्यूशन क्या है? इंस्टेंटेनियस है, बट एलिमिनेशन क्या होता है? फर्स्ट ऑर्डर काइनेटिक्स को फॉलो करता है. नाउ व्हाट इज फर्स्ट ऑर्डर काइनेटिक्स? फर्स्ट ऑर्डर काइनेटिक्स मींस द रेट ऑफ elimination of drug from the body is proportional to the amount of drug that is present in the body. मतलब किस रेट पे बॉडी से ड्रग एलिमिनेट हो रहा है वो किससे डिपेंडेंट होगा? कितने बॉडी पे ड्रग प्रेजेंट होता है. सो व्हाट डज इट मीन? एलिमिनेशन फॉलोज फर्स्ट ऑर्डर काइनेटिक्स मीन्स the rate of elimination of drug from the body is proportional to the amount of drug that is present in the body. So the rate of elimination can be written as minus dx upon dt. Dx upon dt is the rate minus, as elimination takes place, the drug concentration in the body decreases. So concentration decrease होगा elimination होने की वजह से, इसलिए हम क्या साइन लिख रहे हैं? माइनस. dx upon dt is rate. rate मतलब d is change, छोटा सा चेंज होता है उसको बोलते हैं. x is amount. x किसके लिए लिखते हैं? अमाउंट के लिए लिखते हैं. सो द चेंज इन अमाउंट विद रिस्पेक्ट टू किसके हिसाब से? टाइम के हिसाब से. जैसे जैसे टाइम चेंज होता है, बॉडी में ड्रग एडमिनिस्टर किए उसका अमाउंट भी चेंज होगा. किसके हिसाब से चेंज हो रहा है? हमारे बॉडी से. क्यों चेंज हो रहा है बॉडी से? because the drug is eliminated. distribution instantaneous हो गया, but eliminate हो रहा है बॉडी से, रहता ही नहीं है ड्रग. it will not reside always in the body, it will remove out of the body. so when it removes out of the body, amount of drug in the body decreases. डिक्रीज होना है, इसलिए हम क्या साइन लिखेंगे? माइनस लिखते हैं. सो रेट को कैसे लिखना है? माइनस dx अपॉन dt. डिपेंडेंट के लिए we use the mathematical symbol that is proportional to the amount of drug that is present in the body. कितने amount of drug बॉडी में है वो किसके हिसाब से होता है? rate of drug that is present in the body or eliminated out from the body. बॉडी से जैसे जैसे eliminate हो रहा है उसके हिसाब से कंसंट्रेशन या अमाउंट आपके बॉडी के अंदर डिक्रीज होते जाएगा. सो इट कैन बी एक्सप्लेन्ड एज दैट इज व्हाट फर्स्ट ऑर्डर काइनेटिक्स. फर्स्ट ऑर्डर काइनेटिक्स मतलब क्या होता है? रेट इज प्रोपोर्शनल टू द अमाउंट. सो द रेट ऑफ एलिमिनेशन इज प्रोपोर्शनल टू अमाउंट. सो इसको लिखना है तो dx अपॉन dt. इफ यू इक्वेट this, minus will come here, so minus k into x. Now this k is known as apparent, you have to mention overall apparent first order. ये कौन सा constant kinetics है? first order kinetics. That's why this elimination rate constant is also first order elimination rate constant. So what is this k? K is overall apparent first order elimination rate constant. Since elimination is following first order kinetics, it is known as first order elimination rate constant. K you know already, it is a constant. यहाँ पे कौन सा constant है? इसको क्या explain करना है? elimination rate को explain कर रहा है. तो ये कौन सा constant होगा? elimination rate constant होगा. So elimination rate constant. ये कौन सा order follow कर रहा है? first order. इसलिए इसको first order rate constant बोलते हैं. Why it is overall apparent बोलते हैं? Because this k includes sum of many other rate constants, which is km plus ke, which is rate constant of metabolism, rate constant of excretion. Again this km has pathway 1 and pathway 2. Already in metabolism we discussed there are two pathways. One is functionalization pathway and another is conjugation pathway. For those two pathways, one pathway phase 1 pathway के लिए m dash and double dash for phase 2 pathway. So two rate constant for metabolism and two rate constants for excretion. Again in excretion we discussed two excretion. One is renal excretion and another is non-renal excretion. Sum of all these rate constant is considered to be the k, which is overall. इन सबको मिला के बोल रहे हैं इसलिए overall apparent first order elimination rate constant, that is k. इस k को बोलते हैं which follows the first order kinetics. So when the drug is administered and that follows first order one compartment model pharmacokinetics, drug को input को generally when you explain this compartment model, horizontal arrow or the forward arrow is used for explaining the movement of drug. Here you are administering the drug into the body. Elimination can be signified or symbolized by using downward arrow. So drug is administered to the body, इधर सब distribute होके बाहर निकलता है and the rate constant here is k, which is elimination rate constant. Got it? अब ये जो इसके अंदर we have one constant which is elimination rate constant. Now if you need to explain graphically time or concentration in case of IV dose पे देते हैं तो IV में immediately 100% पहुंचता है, वहां से drug concentration decrease होता है, exponentially decrease हो रहा है, and we get generally mono exponential curve in for one compartment model. This is again important in competitive exams. Competitive exams में ये पूछते हैं one compartment model किस तरीके से कर्व देता है, मोनो एक्सपोनेंशियल बाय एक्सपोनेंशियल. IV देते हैं तो इसका जो कर्व जो है मोनो एक्सपोनेंशियल कर्व मिलता है. एक्सपोनेंशियल मींस इट इज नॉट अ स्ट्रेट लाइन. स्ट्रेट लाइन नहीं होके कर्व आता है तो उसको क्या बोलते हैं, एक्सपोनेंशियल बोलते हैं. बिकॉज इस इक्वेशन को आप एक्सटेंड करके देखेंगे तो क्या होगा, xt इज इक्वल टू x नॉट इंटू ई टू द पावर माइनस kt. इसका जो इंटीग्रेटेड टर्म जो है आपका एक्सपोनेंशियल होगा, विच विल नॉट गिव यू स्ट्रेट लाइन, और ग्राफ देखेंगे तो आपको कर्व मिलेगा एक्सपोनेंशियल. मोनो क्यों बोलते हैं, एक ही कर्व मिला. व्हाई ओनली वन कर्व, बिकॉज हियर डिस्ट्रीब्यूशन इज इंस्टेंटेनियस, बट डिस्ट्रीब्यूशन दिखता ही नहीं है, अब्सॉर्ब होके डिस्ट्रीब्यूशन इंस्टेंटेनियस, तुरंत जैसा ब्लड में गया हर टिश्यूज में चला गया, इंस्टेंटेनियसली इट हैज रीच्ड द डिफरेंट टिश्यूज व्हेन इट एंटर्ड इनटू द ब्लड. पर दिखता क्या है, इट विल बी द एलिमिनेशन. द एलिमिनेशन decreased. Elimination होने की वजह से concentration of drug will be decreased in the body. That is visible in the graph. So ये जो face है यहाँ पे curve में दिखता है, this curve is known as exponential curve because of elimination. Elimination can be explained by this exponential curve, जिससे elimination rate constant determine करते हैं. So in case of one compartment model, what all the things to be remembered here? Distribution is instantaneous. Elimination follows first order kinetics, and K, which is the rate constant, which is having the unit of, इसका unit K का unit क्या होगा, टाइम का इनवर्स का जो भी यूनिट. टाइम मिनट में होगा तो मिनट इनवर्स, हार्स में होगा तो हावर इनवर्स. How the unit has been derived, that I will derive and show it later in my next videos. Now one compartment model, another thing to be remembered is that the curve explained by this one compartment model shows mono exponential type of curve. Now moving on to two compartment. So we have another compartment model, which is two compartment model. Here the body will be divided into two compartments. One is central compartment and another is peripheral or tissue compartment. So here the depiction will be like this. The first compartment and the second compartment. First compartment is central compartment and second compartment is peripheral or tissue compartment. Once you administer the drug in the body, in case of this two compartment model, it will not immediately instantaneously distributed. Here the drug will reach the central compartment, which will consist of plasma and highly perfused organs except brain. If polar drug, brain will be here. If it is a lipophilic drug, brain will be here in central compartment. Now the drug reached the central compartment, and from here it will be redistributed to different tissues. That is from central compartment to tissue compartment. That is from first compartment to second compartment the drug will be distributed, and once equilibrium will be achieved or the maximum saturation will be achieved, the backward movement, that is from tissue compartment the central compartment, the drug movement will be there. So movement of drug from first to second compartment is the rate constant K12, whereas the movement of drug from second to first compartment is known as K21. K12 means 1 to 2, first compartment to second compartment. Here the movement takes place from second to first compartment. So now the drug has distributed from central compartment to tissue compartment and tissue compartment to central compartment. These two are known as transfer constants or distribution constants. Now after distribution the drug have to be eliminated. Now where the arrow will be, in case of one compartment I mentioned the arrow, downward arrow, it is since it is a single कंपार्टमेंट, तो वहीं पे ही एक ही कंपार्टमेंट से नीचे एलिमिनेट हो गया. अब कहाँ से एलिमिनेट होगा, सेंट्रल कंपार्टमेंट या टिश्यू कंपार्टमेंट, कहाँ पे हमें एरो देना होगा, कहाँ पे देना होगा, इट इज इन फ्रॉम central compartment. Why we have to place this arrow that is of elimination in central compartment? Elimination is done by liver and kidney. Both are highly perfused organs and both will be in central compartment. That is why the downward arrow should not be from पेरिफेरल कंपार्टमेंट, इट शुड बी फ्रॉम सेंट्रल कंपार्टमेंट. यहाँ पे होगा आपका एलिमिनेशन का एरो, क्योंकि एलिमिनेशन कहाँ होगा? किडनी और लिवर में होगा, और दोनों ही कौन से कंपार्टमेंट में रहेगा? सेंट्रल कंपार्टमेंट, बिकॉज दोनों ही हाईली परफ्यूज्ड ऑर्गन में आता है. सो वी हैव हियर थ्री कांस्टेंट्स K12, K21 एंड K विच इज एलिमिनेशन. ये दोनों डिस्ट्रीब्यूशन का कांस्टेंट हो गया, K जो है एलिमिनेशन रेट कांस्टेंट हो गया. पहले ही बोल दिए, ब्रेन परमेबिलिटी के हिसाब से आपका पोलर रहता है टिश्यू कंपार्टमेंट में रखेंगे, और आपका लिपोफिलिक ड्रग रहता है वो सेंट्रल कंपार्टमेंट में रहेगा. नाउ व्हेन यू मेक अ ग्राफ, इसका ग्राफ बनाएंगे तो कंसंट्रेशन में पहले आपको ड्रग का डिस्ट्रीब्यूशन होगा आपके प्लाज्मा से टिश्यू कंपार्टमेंट तक, उसके बाद एलिमिनेट होगा. सो टू कर्व्स आर देयर, फ्रॉम हियर टू फ्रॉम हियर इट इज डिस्ट्रीब्यूशन फेज, and from here to here it is known as elimination phase. Like in case of drugs like ultra short acting barbiturates, thiopentone sodium, it is ultra short acting. मतलब thiopentone sodium तुरंत ही उसका एक्शन शुरू हो जाता है, तुरंत ही खत्म हो जाता है. Why? Because it reaches the brain immediately. वो सब क्या है? अल्ट्रा शॉर्ट एक्टिंग सेडेटिव हिप्नोटिक ड्रग्स में आता है, बार्बिट्रेट्स में आता है, तो तुरंत ब्रेन में जाएगा, बट इमीडिएटली इट विल गेट रीडिस्ट्रीब्यूटेड फ्रॉम ब्रेन टू डिफरेंट ऑर्गन्स, सब टिश्यूज में चले जाता है. सो डिस्ट्रीब्यूशन फ्रॉम प्लाज्मा टू डिफरेंट ऑर्गन्स, उसके लिए एक, और एलिमिनेशन बॉडी से एलिमिनेट हो रहा है उसी की वजह से और डिक्रीज हो रहा है. सो आपको टू कंपार्टमेंट मॉडल में किस तरीके से ग्राफ मिलेगा? बाय एक्सपोनेंशियल ग्राफ मिलेगा. सो मोनो एक्सपोनेंशियल इन वन कंपार्टमेंट, और आपका टू कंपार्टमेंट मॉडल में बाय एक्सपोनेंशियल टाइप ऑफ कर्व मिलेगा. whereas थ्री कंपार्टमेंट मॉडल, अब हम थ्री कंपार्टमेंट कंसिडर करते हैं, तो थ्री कंपार्टमेंट में क्या है? वी हैव सेंट्रल कंपार्टमेंट, और बॉडी में आपको शैलो टिश्यू कंपार्टमेंट and deep tissue compartment. This is first compartment, this is second compartment, this is third compartment. मतलब central compartment मतलब प्लाज्मा और हाईली परफ्यूज्ड ऑर्गन. लेस परफ्यूज्ड ऑर्गन आपका शैलो टिश्यू कंपार्टमेंट में होगा, वेरी लेस परफ्यूज्ड ऑर्गन आपका डीप टिश्यू कंपार्टमेंट में आएगा. यहाँ से यहाँ मूव होके यहाँ से यहाँ मूव होगा, उस तरीके से ऐसे मूव होगा. बट इफ यू सी दैट द सेंट्रल कंपार्टमेंट विच हैज प्लाज्मा, एक्चुअली क्या होता है? ब्लड इज डिस्ट्रीब्यूटेड टू ऑल द टिश्यूज. ब्लड जो है एक के लिए कॉमन नहीं है, सिर्फ शैलो के लिए बस ओपन हो रखा है इस केस में, बट ब्लड जो है इधर भी ओपन होता है, इधर भी ओपन होता है. बट इस डिपिक्शन में हम क्या कर रखे हैं? सेंट्रल कंपार्टमेंट इज कनेक्टेड ओनली टू शैलो, नॉट टू डीप टिश्यू कंपार्टमेंट. इस मॉडल को क्या बोलते हैं? कैटिनरी मॉडल बोलते हैं. जैसे गाड़ी चलता है, जैसे कार्ट चलता है, वन कंपार्टमेंट देन सेकंड देन थर्ड, लाइक इन रेल में ऐसे ही होता है. फर्स्ट कंपार्टमेंट, फिर सेकंड कंपार्टमेंट, थर्ड कंपार्टमेंट. फर्स्ट कंपार्टमेंट के साथ तीसरे वाले का कनेक्शन नहीं होगा. बट बॉडी में ऐसा होता है क्या? नहीं होता है. Blood will be distributed throughout the body, even if it is deep tissue compartment, very deep tissue compartment, जो भी होगा blood पहुंचता ही पहुंचता है. So blood should have connection to this as well as to this. This model is known as catenary model. इसका ड्रॉबैक होने की वजह से हम दूसरा मॉडल करना चाहिए, which is known as mammillary model, where the central compartment will be placed in between and the two compartments adjacent to it. Just उसके sides में, besides the central compartment, on one side shallow tissue compartment, on another side deep tissue compartment. ये first compartment हो गया, ये second compartment हो गया, यहाँ third compartment. इसमें drawback क्या है? Central compartment third compartment में connection नहीं. यहाँ देखो first compartment is connected to second compartment. Now first compartment is also connected to the third compartment. अब एलिमिनेशन कहाँ से होगा? सेंट्रल कंपार्टमेंट से होगा. यहाँ पे आपको कांस्टेंट देखेंगे तो K13, K31, that is 1 to 3, 3 to 1 and K1 to 2, that is K1 to K2 to 1, K2 1. इतने सारे आपको constants involved होता है. This is all about compartment models. So compartment models में हम 1 compartment, 2 compartment, multi compartment. Multi compartment में 2 होता है, catenary and mammillary model. इतना discuss किए. We have further non-compartment method and perfusion and physiologic method. वो next videos में discuss करेंगे. We will discuss in the next videos the other 2 models. Today we will discuss only about the compartment model. So even classification, if it comes in 10 marks, after classification you have to explain. So you have to explain this as compartment models. If it is only asked about compartment models, you can explain like this. So next video we will discuss about perfusion model and non-compartment model. Thank you.